Once again, we continue with our exercises of finding critical numbers. Second, finding intervals of increasing and decreasing. Third, finding relative min and max using the first derivative test. First derivative test again is when the first derivative changes from negative to positive, that indicates the function was decreasing to increasing, and that's a minimum. When the first derivative changes from negative to positive, that indicates a minimum. When the first derivative changes from positive to negative, that indicates a maximum. Min, max. And that's all there is to it. Alright, let's go on with number 33. We have f of x is equal to 2x plus 1 over x. Before you get started, always think about the function a little bit. This is a function that is not defined at x equals 0. So x equals 0 is not going to be a critical number. However, it is going to be important in our analysis. So let's do our work here. I can rewrite this as 2x plus x to the negative first. F prime of x is 2, then minus x to the negative second, which can also be written as 2 minus 1 over x squared. So we want to set that equal to 0. 2 minus 1 over x squared equals 0 when 2 is equal to 1 over x squared. Cross multiply however you want to solve this. We get 2x squared is equal to 1. X squared is 1/2, and so x is going to be not plus or minus 1/4, it's plus or minus 1 over the square root of 2, which is plus or minus root 2 over 2. Now, I'm not sure if I mentioned this before. You should have a way to estimate square root of 2. Square root of 2 is roughly equal to 1.4, so square root of 2 over 2 is roughly equal to 0.7. So we'll need that when we go on to our sign chart, which is right now. So remember that we had a vertical asymptote at 0, and we have negative root 2 over 2 and positive root 2 over 2, which are roughly about negative 0.7 and positive 0.7. So we can use negative 0.5, negative 1, 0.5, and 1. And again, we're working with the first derivative. Now, where is our first derivative? Our first derivative, the easiest form to work with, I think, is going to be this form right here. So let's see, when we plug in negative 1, we're going to square that, and 1 over 1 is 1, 2 minus 1 is positive. Negative 0.5, negative 1/2, we square that, we'll get 1/4. 1 over 1/4 is 4, 2 minus 4 is going to be negative. And the same thing will happen with 0.5 positive. We will get 2 minus 4, which is negative. Plugging in 1, again, is positive. So we have here the function is decreasing from negative root 2 over 2 to 0. And then again, we can't include 0 in there. We can't just do the whole thing from negative root 2 over 2 to positive root 2 over 2. We have to break it up. Root 2 over 2 0 to root 2 over 2, it is increasing from negative infinity to negative root 2 over 2, and it also increases from root 2 over 2 to infinity. Next, when do we have any extrema? Well, we do have a change from increasing to decreasing here, and from decreasing to increasing there. And so we have a relative min. Let's do the max first. Relative max at negative root 2 over 2, and a relative min at positive root 2 over 2. Is it easy for us to figure out what the y values will be there? We have x is negative root 2 over 2. That's going to be negative root 2 plus 1 over. Alright, let's see what we have. F of negative root 2 over 2 is 2 times negative root 2 over 2 plus 1 over negative root 2 over 2. So this will leave just negative root 2 over 2, and the other will be flipped so that it will be minus 2 over root 2, which when we rationalize, we get negative root 2, then minus root 2, so that will be negative 2 root 2. Wow, a lot of work there. Negative 2 root 2. And for the next one, we have f of root 2 over 2. So that is 2 times root 2 over 2. We know that that will just become root 2. Then plus 1 over root 2 over 2. We'll flip that to get 2 over root 2. We'll rationalize that, and we end up with root 2 plus root 2, or 2 root 2, and you can see why calculus is an exhausting subject, especially when you're not allowed to use a graphing calculator. It is requiring so much prior knowledge and so much information that really has to be very solidly in your grasp. Let's see for 1 second here. I'm a little concerned because my maximum is negative and my minimum is positive. But still, that appears to be the way that it is. It doesn't make sense to me, and I have a feeling that it's not right. But we're going to call in the graphing calculator and take a look at this. Alright, so our function is 2x plus 1 over x. And zoom standard. And let's see what we get. We said our maximum was negative and our minimum was positive. So actually we were right on there. And you can see that this is a very unique type of function here. And I'm going to take a picture of this and we'll add it to our workspace. Okay, and that's going to be the only one that we'll be able to do on this page here, since that used up all of the workspace. But we did everything correctly, and hopefully you can get some appreciation for how complicated this the subject really is, the algebra involved in it, more than anything else. All right, we'll go on to the next, to number 35 in the next video.